Today we are moving on to fourth degree polynomials or quartic functions and some that are even higher. The good news is it's exactly the same method. You're going to find the P's and Q's, you're going to use your calculator to get started, and then once you do, you're going to work on it till you get it down to a quadratic, and then you'll use factoring techniques or the quadratic formula to get the other roots. So it's going to be pretty much the same method. So here are some examples. So starting with the possible irrational roots, this one kind of nice because we're back to this idea with just a 1 in front. My calculator disappeared. So our possible irrational roots are just plus or minus 1, 2, 3, and 6. So I'm going to use my calculator. I already have it plugged in here, and I'm going to change my table set back to 1 since I don't need it to be on fractions. And I can see, actually I'm going to use the 1. I see 1 works. Actually I see 1 works, I see 2 works, I see -3 works. Keep that in mind. So I'm going to use a 1 and do synthetic division. We're going to put a 1x to the 4th, 1x cubed, -7, -1, and 6. So bring the 1 down and I'm going to multiply, add, multiply, add, multiply, add, multiply, and notice we get 0. So I know that x minus 1 is a factor because when I divided with 1, I got 0. Now, before I go on, I already know that a 2 is also going to work. So I'm going to do synthetic division with a 2, but you don't have to like start over. Just keep going. So I bring a 1 down. 2 times 1 is 2. Then I add, multiply, and add, multiply, and add. And so I know, since I got 0 for a remainder, x minus 2 is a factor. Okay, that's where I want you to stop using your calculator once you found the first 2. And then what's left? Well, if I started with x to the 4th, after my first synthetic division, this leading coefficient would have been x cubed. And then when I did it one more time, now my leading coefficient is x squared. So I have an x squared plus 4x plus 3. Now I want you to use what we already know how to do. So you can do a diamond problem to factor that. So we're going to have a 3 and a 1. They multiply to 3 and add. So we end up with f of x equals x minus 1, x minus 2, x plus 3, and x plus 1. So those would be all my factors. That's my factoring. So I have a root of 1, 2, -3, -1. They are all rational. They are all real. For the next one, again, we have a 1 in front, so that makes life a little easier, but not much because 36 has a lot of factors. So we have plus or minus 1, 2, 3 goes evenly, 4 goes evenly, 6 goes evenly, 9, now I'm just looking for the factor pairs that went with these earlier numbers, 3 times 12, 2 times 18, and then 1 times 36. So all of those are potential possible rational roots. So we're going to use our calculator to get started. And I see that 3 works, so I'm going to use a 3. But notice -3 also works. We might want that. So we have 1, -4, -5, 36, -36. So I multiply and add, multiply and add, multiply and add, multiply and add. So because 3 worked, x minus 3 is a factor. But we only have it to cubics now, and we want to try and get it down one more. So we already know -3 works using our calculator. So then okay, and this is what I have left. So we know that x plus 3 also works, and I'm left with x squared minus 4x plus 4, which I think is factorable. So if we do a diamond problem for that, you get -2 and -2. So we're going to have f of x equals x minus 3, x plus 3, and that's going to be x minus 2 quantity squared. So then I get a 3, a negative 3, and a 2 with a multiplicity of 2. They are all rational, and they are all real. All right. So next, our possible rational roots, plus or minus 1, 2, 4, 8, and 16. So those are all the numbers that go into 16 evenly. We plug it into our calculator, help us out to get started. I see negative 2 works. I'm also noticing that 4 works. So I'm going to have a 1, no x cubed, so don't forget the 0. Negative 14x squared, negative 12x, and a plus 16. Okay, good. We got 0, and now I'm gonna write down, since negative 2 worked, x plus 2 is a factor, and I'm also using my calculator to see that 4 works. So I'm going to continue synthetic division with that. So since 4 works, x minus 4 is a factor, and I'm left with x squared plus 2x minus 2. And actually, that one is not factorable. So if you try a diamond problem, it will not work. So for my factorization, I'm done. But then I'm not done with my roots. I know that negative 2 and 4 are both rational and real, but now I have to deal with this other one. So when I set this equal to 0, I'm going to use the quadratic formula. So x equals opposite of b plus or minus square root b squared minus 4 times 1 times negative 2 all over 2. So we get negative 2 plus or minus the square root of 4 plus 8, so we get a 12. I can simplify that because there's a perfect square in there. I can think of 12 as 4 times 3. The square root of 4 is 2. And then I can divide out of 2. So I get negative 1 plus or minus 1 root 3. So I have negative 1 plus root 3, negative 1 minus root 3. They are both irrational and real. They're not imaginary because we don't have eyes in them, which means that if I graph this, it's going to cross 4 times. To know where it crosses here, I'd want to use my calculator and get an approximation if I actually had to graph those. So for the next one, our possible rational roots, everything that goes into 40 evenly, we end up with plus or minus 1, 2, 4, 5, 8, 10, 20, and 40. Those are all the factors of 40. And we use our calculator to help us get started. And I see that 2 is a factor. I also see that negative 4 is. I'm going to start with the 2. So I have 1x to the 4th, 2x cubed minus 3x squared, 10x minus 40, and dividing with a 2. And we get 0, which is good. And then I said negative 4 works. So since the 2 works, we know x minus 2 is a factor. Since negative 4 works, we know x plus 4 is a factor. And we're left with x squared 0x plus 5, which I know from looking at it, you can tell it's not factorable. So then our factorization is just x minus 2 times x plus 4 times x squared plus 5. We have a 2 and a negative 4 that are rational and real, but then we have to solve this. X squared plus 5 equal to 0, so x squared is equal to negative 5, so x equals plus or minus the square root of negative 5, which is plus or minus I root 5. So we get I root 5 and negative I root 5. Those are both imaginary. These are considered pure imaginary. So, which means that this only crosses the x-axis twice because these imaginary roots tell us it's not going to cross there. But that would be our answer for that problem. So you should be noticing after a while, these all feel the same. So as you practice, you're going to get really good at these. You're also going to get really good at solving quadratic equations because you have to do it a bunch. So possible rational roots for this one, because we do have a 4 out front, it's a little different. So for our p, which comes from this back part here, the constant, we have plus or minus 1 and 2. And for the q, we have from this 4, we get plus or minus 1, 2, and 4. So for our p over q, we get plus or minus 1 over 1, which is 1, or 1/2, or 1/4, or 2 over 1, or 2 over 2, which we already have because it's 1, or 2 over 4, which we already have. So these are our possible rational roots. And I think I have this typed in. Yep, so let's get started, find one that works. And notice that none of these do. So the 1 and the 2 must not work, so it's going to be a fraction. So I'm going to go into my table set and switch this to 0.5 and see if that is good enough. And we'll see, yep, 0.5, 1/2 is a 0, so 1/2 works. So I'm going to have a 4, a -4, a -7, an 8, and a -2. So I bring the 4 down. Half of 4 is 2, and then I add. Half of -2 is -1. Half of -8 is -4, and half of 4 is 2, and I get a 0. So then when I look and I see, okay, where's another one? And you could check and see if a 4th works. If you plug in a 4th, we could change this. I'll change it to 0.25 so that we can find that. So now I have to go, oh, right here. And 0.25 doesn't work, and neither does -0.25. So there aren't any other. So then all you have to do is hope. Oh, maybe a half works again. So I'm going to try a half again and see if it works. So a 4 comes down. Half of 4 is 2. I add and I get 0. Half of 0 is 0, and I add and get -8. Half of -8 is -4, and when I add that to the 4, I get 0. So it did work again. So we have an x minus a half and an x minus a half, and what's left? 4x squared minus 8. Well, we have that awkwardness again. So I'm going to do this. X minus a half, x minus a half, and I'm going to take the 4 out of this, and I get x squared minus 1. Now, 4, I'm sure you all agree, is 2 times 2, right? So I'm going to take a 2 and multiply it into here, and another 2 and multiply it into here. So when I do that, I end up with, because I'm taking that 2, so I get 2x, and 2 times a half is just 1, so I get 2x minus 1. And this other 2 I put into this other factor, and then I'm left with x squared minus 1. So I factored a 2 out and put it in the first one, factored a 2 out, put it in the second one, so that it looks better. Now, this is the difference of 2 squares, so we get f of x equals 2x minus 1 quantity squared times x plus 1 times x minus 1. My roots would be a half with a multiplicity of 2, a -1, and a +1. I thought those didn't work. Okay, I suppose I can't really rewind. Well, I could, but I'm not going to. It would be nice if I had done that part right. I know probably some of you were going, you did that wrong, you did that wrong. So, and now I see that. That doesn't change this 4 and switching that, but now I have an x squared minus 2, which is not the difference of 2 squares. So we leave that as x squared minus 2. Awfully glad I caught that before I had gone on to everything else. So these are not there. So this last part, if we take x squared minus 2 and set it equal to 0, I get x squared equals 2. So x equals plus or minus the square root of 2. So I have the square root of 2 and negative root 2. So the first one is rational and real. These are irrational and real. And those would be my roots. What if you have a fifth degree polynomial? No big deal because you're doing the same stuff. So the possible rational roots, this time the leading coefficient is 1, so it's just plus or minus 1 or 5. So those are the only possibilities. I'm going to go back to my, set this up just as a increment of 1. And we are looking for one root to help us get started. Why did that not? I thought I set that up. Oh, let me just start this at 0. Okay, so I can see 1 works. So let's try a 1. Write small. So I have 1, negative 7, 10, 2, negative 11, and 5. So I'm going to bring the 1 down. And that works. So we know x minus 1 is a factor. Let's see if negative 1 works. So I'm going to try a negative 1. So I bring a 1 down. Wait, did I do that right? Yep. You can always tell by the end that you get it right. So negative 1 works because I got 0 remainder. So that means x plus 1 is a factor. Now, the problem is I started with 5th power, then I went down to the 4th power, now I'm at the 3rd power, and I still am not down to a quadratic. So I need another one that works. Well, if you just look on your list, see that you have a 5 that works. So do it again. So I'm going to bring down the 1. I'm going to be down here below here. So we have a 5, which gives me a negative 2, negative 10, which gives me a 1, and a 5, which gives me a 0. So 5 works, so that means x minus 5 is a factor. And I'm left with x squared minus 2x plus 1, which is factorable with a diamond problem. You get x minus 1 times x minus 1. You can verify that. So then f of x equals x minus 1 quantity cubed, looks like I have 3 of those, times x plus 1 times x minus 5. So I have a 1 with a multiplicity of 3, a negative 1, and a 5. All are rational, and all are real. So it's really not that big of a deal. You just have more synthetic division to do, and aren't you happy that I let you use a calculator to find that, and you don't have to do synthetic division and have all this trial and error. So this one, possible rational roots, again, it's just a 1, so we get plus or minus all the factors of 48, and there's a lot. 1, 2, 3 goes evenly, 4 goes evenly, 6, and 8. And now working backwards, 4 goes into 48 12 times, so 12 goes. 3 goes into 48 16 times, so 16 goes. 2 goes into 48 24 times, and then we have a 48. So these are all the possible rational roots. So to get started, I see that 2 works. And I also see that negative 3 works. So I'm going to try 2. I'm going to do mine down here because with all of those, because, yeah, it just takes up a lot of space. Notice there's no cubic, so I need a 0. All right, so we start with that 1. And that is, I think, 28. Okay, so that works. And then, which means x minus 2 is a factor. And then we said, that was the 2, we said negative 3 works. 8. Okay, but the problem, so we know x plus 3 is a factor, but now the problem is they, this is just a cubic, and I don't know, there's no others. If you look through the list, there's no others, which means my only hope then is that either the 2 or the -3 is going to work. So we're going to just try it. So I'm going to try a 2 and hope it works. It worked. Okay, so now that so you just have to try something again. So that means I have another factor of x minus 2, and now what's left? I have x squared minus 4x plus 4, and I believe that is factorable. X minus 2 times x minus 2, you can do with a diamond problem. So then we end up with f of x equals x minus 2, we got 4 factors of those, times x plus 3. So we have 2 with a multiplicity of 4, and we have -3. Both are rational, both are real. So on this next one, and you might be wondering, why is she doing so many examples? Because there's just something slightly different about all of them. And if I don't do that, then when you're trying to do the problems, then you would complain that I didn't do any like that. So possible rational roots on this, plus or minus 1, 2, and 4. Plug it into our calculator and see what we can do to get started. I see that 1 works. I also see that 4 works. So I'm going to start with 1. Nothing skipped, so we're good there. Okay, so that worked, and then let's try the 4. So I know that x minus 1 is a factor. And 4 works, so we know x minus 4 is a factor. And if you scroll through, you'll find that no others work. So then you're hoping that one of these works again. Now, if you wanted to be for sure, like you didn't want to guess, well, it's probably just easier. But what you could do, remember this is x cubed minus x squared plus x minus 1. So you could actually graph this and do the same process and then try the 1 and the 4, because actually then plus or minus 1 would be your only option, and you could try the plus or minus 1. So in all honesty, this just tells me something. If one of them works again, it can't be the 4 because a possible rational root of my depressed polynomial does not include a 4. It would only include plus or minus 1, so it must be a 1. Oh, that's a new discovery, you guys. So we end up with always learning new things. And so this is squared, so we had 2 of those. And then we end up with an x squared plus 0x plus 1. That cannot be factored. So we have f of x equals x minus 1 quantity squared times x minus 4 times x squared plus 1. So my roots, I have a 1 with a multiplicity of 2. And I have a 4. Both of those are rational and real. But then x squared plus 1, setting that equal to 0. So we get x equals plus or minus the square root of -1, which is just plus or minus I, pure imaginary. So we get I and -I, which are both imaginary. So there we have that one. I went to go to the next slide, and that was it. So that takes care of those problems. We didn't have any with coefficients in front of the x to the 5th. It just adds another level of complexity, but still the same process. So this should take you through your homework packet.